Hello, so this video lecture is going to help you answer or do the notes for our periodic table and reactivity. Your notes say modified as well. They're fill in the blank. They're guided notes. We've seen guided notes before. All you're going to do is fill in the blank with the missing information. Once you're done, take a picture and submit it on Canvas. So we've talked a lot about the periodic table already. Yesterday we talked about who formed the periodic table or who we credit for it, how he formed it, and why he formed it that way. We learned that Dmitri Mendeleev was very obsessive with his study of the periodic table, and that's ultimately what led to his success. Today we're going to be answering the questions: how do valence electrons determine an atom's chemical properties, including reactivity? Remember, the periodic table before Mendeleev was indeed formed in increasing atomic weight, which, remember, is not the same as mass, but it was similar enough that Mendeleev used mass to order the elements, but he did repeating rows based on reactivity of elements. We'll learn that these valence electrons are actually what are responsible for that reactivity or chemical properties of the element. Remember, we said our alkali metals, the group number 1, the first ones, those are very, very reactive. Turns out it's because there is one extra valence electron. We'll learn about that as well, and then we'll also talk about how elements are classified on the periodic table, which we've already talked about a little bit. Just a reminder and a refresher, the atom is the basic unit of chemical elements, so we can have an atom of gold, an atom of oxygen, an atom of mercury. We know that. We know that when two atoms bond together, we get a molecule, but when we're talking about just one single thing, it's an atom. We said that we can divide the atom into 3 basic parts, but we need all 3 parts for my atom to work: a proton, a neutron, and an electron. Remember, protons are positively charged and they are very massive. We find them in the nucleus, like our picture right here. Our protons are red. We have neutrons as well in the nucleus. They are, again, massive. They are green in our picture. They are not electrically charged. We call them neutral. And those are our 2 massive particles. That's why they're in the middle. The electrons are not very massive at all. They don't have a lot of matter in them, so they rotate around the outside of the nucleus in what we call the electron cloud. Remember, electrons are negatively charged. The atomic mass is the sum of the protons and neutrons. I just said electrons really aren't massive, so we don't include those into our atomic mass. Electrons, again, are a negatively charged subatomic particle. So subatomic, the small part of my atom, they're negatively charged. They're located outside of the nucleus. We just said all that. Valence electrons, though, this is where the new stuff starts. A valence electron is an electron in one of the outer shells of an atom that can participate in forming chemical bonds with another atom. So we haven't really talked about our electron shells yet, but I will tell you that they are what quote-unquote hold. It doesn't actually look like this, but for the purposes of 8th grade science, this is what we're going to think of them as. They're like rings. The very first ring can only have 2, and then the rest of the rings, until we get way, way far out, can have 8. So if you can see, copper here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 8 in that shell. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 25, 26, 27, 28. They would have expanding out a little bit more, and then our valence electron is that very last one, or in the outer shell. You can see my last shell right here only has 1 extra electron, although this isn't exactly an accurate representation. We'll look at another graph later. The number of valence electrons determines the element's reactivity. That means that however many electrons I have on this outer shell, it's going to determine how reactive or how readily able my atom is at forming bonds. So remember, we said, like, copper is a transition metal. It is not very reactive. That's why we have a copper penny and it doesn't explode in your pocket. It's not reactive because of this valence electron. Our periodic table. So the periodic table is arranges all the known elements in number of increasing atomic number or number of protons, which we gave the, never mind. number of protons, as well as increasing atomic mass, which again is the mass of my proton plus my neutron. We said that Mendeleev helped determine this structure right here based on reactivity of the elements. Now, this is going to be on our whiteboards, so if you are watching this, you'll just do it on a piece of paper, try it, test it. You don't need to turn it in, but it's something that maybe will help you. This SI right here, you should be able to identify that this is my atomic symbol, and you can test yourself. So if you pause this, I'll go through the answers. Silicon is my actual name of my element. 28.086 is my atomic mass, and 14 is my atomic number. Hopefully it looked like this. We talked yesterday about how the periodic table is classified into different parts. Generally, we have metals, nonmetals, and metalloids. Metals are usually solids at room temperature except for mercury. They're shiny, so think your gold, your silver. They're ductile. We talked about this yesterday. That means they bend. They're malleable, which means I can hammer them and flatten them into sheets. They're good conductors of electricity and heat. Remember, that's why we talked about we have copper wires in our houses to help transmit electricity from one place to another. They have high density. Generally, metals will sink. They have a high melting point, which means we have to heat them really heat them up to get them to melt. And generally, the elements at the bottom left corner of the periodic table are most reactive, so our elements right here are most reactive. We said that these elements in the first group are really reactive. This group right here, group number 2, semi-reactive. These transition metals here in the middle, they're just a little bit reactive. Our nonmetals are green here in the periodic table. Typically, they will be gases, but not always. You don't have to write that down, that's not actually on there. They're no luster, they're not really shiny or anything. They don't really conduct heat or electricity very well. They're pretty brittle when you have them in a solid form. They break easily. They're not ductile, meaning you can't bend them. They're not malleable, you can't really hammer them. They have a low density. They have a low melting point, which is why they're often found as gases or liquids. They're hardly ever solids, and they're less reactive than our metals, although remember, just recall that these halogens right here in group number 17 are pretty reactive. And then we have our metalloids, which have characteristics of both metals and nonmetals. They form on that zigzag right here. They're on both sides of the zigzag, the staircase, and they have properties of both metals and nonmetals. This is just to test your knowledge. Go ahead and try it if you would like. Hopefully you were able to identify a Yeti cup as being a metal, carbon in my pencil, a non-metal. Let's make sure. Yep, non-metal. Yellow glob of sulfur is a non-metal. Nitrogen in the air is a non-metal. Silicon used in microprocessors and cell phones, that's a metalloid. Helium in a balloon, non-metal. Aluminum can is a metal. Actually, that might be a metalloid. No, metal. Okay, we're not going to do this part. This, actually, we are going to do another day. I would like you to, so you have a periodic table in your notebooks. If you're online and you didn't print off the notebook, you're going to have to try to get a copy of the periodic table, or you're going to write it down. Not the periodic table, you can write things like group 1 is this is what you should write down. So if you've got a copy of a periodic table, you're going to highlight this one color, group 1, and then I would like you to label them as our alkali metals. Group 2, you're going to color a different color all the way down, and if you're writing these because you don't have a printer, you would write group 2, and they are alkaline earth metals. Group 3 through 12 are considered transition metals. You can draw the staircase in here and copy this picture where we've got my metalloids. You can color those a different color. And then group 17, please color those a new color. Those are called halogens. And group 18, color another color. Those are called noble gases. Very good. Again, the periodic table, the rows on the periodic table are called periods. So rows go this way, so this is period 1, period 2, period 3, period 4, and then going down, the columns are called, oh, that's the next one, groups. Atomic number increases from left to right, so you've got 19, 20, 21, 22, 23. Those in the same period have the same number of energy levels or shells. So that means that this has one, hydrogen has 1 shell, lithium has 2 shells, sodium has 3 cells, as well as magnesium, aluminum, silicon. They don't have the same number of valence electrons, but they have the same number of shells. Chemical properties are not all similar here because we'll learn our groups actually have our chemical properties. So my chemical properties of hydrogen are very similar to lithium, sodium, and potassium. Again, groups go down in the column. They are 1 through 18. They have the same number of valence electrons. That's why they react the same. And they have very similar chemical properties. Group 1, again, is the most reactive. We call those the alkyl metals. That's not right. I don't know why I can't remember. Probably because it's past my bedtime. And group 18 is inert or stable. They don't react at all. Those are called our noble gases. Group 18 starts here with helium, neon, argon, krypton, xenon. We're not going to do this part. We are also not going to do this part either. You've labeled all of what I want to know. Well, we'll do an activity next time about this. But I would like you to know that group 1 has, or period 1 here has 1 shell, period 2 has 2 shells, period 3 has 3, 4 has 4, and so on and so forth. Fantastic. Moving down the period increases the reactivity. So lithium is more reactive than hydrogen, sodium is more reactive than lithium, and so forth. Groups, or columns 1 through 18, have the same number of valence electrons in each group. Valence electrons are the electrons in the outer shell, just remember. A reminder, group 1A, which is right here, the alkyl metal, I still can't remember it. My metals right here have 1 valence electron, and my 5 right here has 5 valence electrons. Reactivity increases as you move from right to left across the metals, and from left to right across the nonmetals. That means that my most reactive, I don't think that's right. Oh, it is right. Okay. So my most reactive elements, you don't need, this is a confusing way to state that. My most reactive of my nonmetals are group 17, the halogens. The most reactive of my metals are my alkyl metals. Group 1. The closer I get to group 1, the more reactive. That means group 2 is semi-reactive. These are less so reactive. So the closer I get there, I'm becoming more reactive, and the closer I get over here to my halogens, the more reactive I become. The ability of atoms to combine or separate with outer atoms to create new substances, that's how our chemical reactions form. Valence electrons are key to this process. Reactivity changes across the periodic table, and we'll discuss valence electrons in another video lecture.